perhaps it's a good idea to go further talking about schematics from the 1960s and the 1970s. I got so many views, I had not expected that at all. Anyway, this is, so thanks for all these views. Circuit diagram of the crystal oscillator. Well, this is a crystal oscillator made with an OC44. That's a PNP germanium transistor. Perhaps you can find it now. And it was a typical high frequency transistor. Germanium high frequency transistor. In those days, 1960s, 1970s, early 1970s. So anyway, I think this can work very nice. This is 100 kilocycles crystal. Well, perhaps it will not be very easy to find that crystal, but anyway, I think it can work nice. And here you can set, say, the coupling to the crystal. And that coupling is also responsible for the oscillation or not. It's going from 0 to 60 picofarad. And this is a 220 kilo ohm resistor. When you want to use it with a typical silicon transistor, you can use here, and in my opinion, my first idea, the BC557. That is a PNP silicon transistor here with a much higher amplification factor. But I think that can work. You can do some experiments by tweaking with the value of this resistor and this resistor, and also this resistor here is positive 5 volt. It's 10 kilo ohms. Well, this acts as a kind of filter in a certain way, and of course you need an output coupling capacitor that is not showed here anyway. And I say that you can use that silicon transistor because the frequency here is very low. The BC557 can handle this, in my opinion. Try, test, experiment. What's this? The very, very popular and standard 7400N chip. It gives a 4 to 8 kilohertz multivibrator for use as a clock. Well, I think this is okay. And by the way, there are also circuits about this on my YouTube channel. When I don't forget it, I will give the link. What's this? Op-amp voltage controlled oscillator circuit. Well, this is interesting in my opinion. This can be a 471, say the father or the mother of all op-amps. Of course it needs a double voltage here. Positive and negative. So go to the data sheet, you can find it on the website of National Semiconductors and also on the World Wide Web. This capacitor sets the frequency. And I don't know the function of the diode, but for instance use here 1 kilo ohm, 50 kilo ohm, 0.1 microfarad. And in that case I think it will work. And here's the control voltage. So you have to vary the voltage between say 0 volts and 10 volts or so. That's my idea. Not very clear about this circuit anyway. What's this? The DNL. I have already talked about it. As far as I can remember, the dynamic noise limiter was invented by Philips. Sony in those days won the war in the 1980s about, say, noise limiting. they developed the Dolby system, Dolby A and Dolby B. In the Dolby system, the high frequencies are, say, lifted up during the recording, but pressed down when the, say, in many cases here, the cassette tape play this music. But this is the Philips invention, dynamic noise limiter. It works, in my opinion, much better, because it only tips off the highest frequency, say in the range of 16 kilohertz, 15 kilohertz. So you can make it yourself now. It was as far as I know, it was a kind of patented circuit in those days. But anyway, now it's everywhere. What's this? Ultrasonic transmitter. Well, that's a good idea. You can make it as a 555 chip. Pin connections are indicated here. Here. So this is 4, 8, 6, 2, 3, 1, and here you need a typical ultrasonic transducer, and that is in general a crystal with a kind of cone connected to it, and it has an endless impedance. That's important to tell. So it drives, the chip drives that specific frequency for which that 40 kilohertz transducer is made. When you use, for instance, a transducer in the order of 20 kilohertz, you need to adapt the frequency that the 555 chip makes to get good results. Anyway, what's this? Armstrong oscillator circuit. No component values. That's always, say, a problem when you look at all these old circuits. There are well, let me explain it a little bit. Use here, for instance, the BC547. Use here a resistor of 1 kilo ohm, capacitor of 1000 picofarad or 10 nanofarad. Use here a potentiometer with a protective resistor here. The wiper goes to the top of the primary coil. Use here a protective resistor and a potentiometer instead of these two resistors in the order of 22K or 25K. This can be 10 nanofarad. And this is very important. There are dots here, and they mean, say, the dot is the top winding of the coil, say where the coil ends, and this is where the coil begins. So it means that you have to connect here this part of the coil reversed. And that has everything to do with the phase. When the phase is not correctly coupled back, the whole thing doesn't work. It doesn't want to oscillate. Very important. When you want to make, say, oscillators with coils, and this regards also, say, a certain bigger principle for e.g. Shortwave oscillators that go from, say, 2 megahertz up to 12 megahertz or so, or even higher. To get such a circuit into oscillation with a coil here and also with a ferrite rod here, the phase must be coupled back in a proper way, and that's done here. Anyway, so let's go to the next circuit. What's this? Rainwater alarm. Well, there are many circuits of rain and water alarms. This is an oscillator that starts to oscillate when here we get a tiny resistance, and that's done by water drops or so. So you can make that sensor with, say, 2 comb-like structures here. And then when water falls along that comb-like structure here, there are many circuits of that on the World Wide Web, by the way, so I don't want to elaborate too much. Two combs here, and when water falls, the whole thing starts to oscillate, or when it gets moist. Speaker and mic preamp. Well, this is interesting. Here are the use a loudspeaker as a microphone. And you can see that it is a grounded base circuit, so that the speaker is connected in the emitter lead together with that voltage supply, 9 volts DC, and these are the component values. There is also on my YouTube channel a circuit where I have used this setup, though in a somewhat other way. I connected the speaker in the base lead, and I will try to give the link to my video and schematic. Armstrong oscillator. Well, this is more or less the most basic oscillator that you can make. PNP transistor, you can use a BC557, 1.5 volts. This transformer will be very, very difficult to find. 90 kilo ohms DC resistance, well, that's extreme, and 5 kilo ohms is also very high. Anyway, you can try to use, for instance, a standard telephone coil with 10K here and 2K here, etc. So, don't know what this is. A Clapp oscillator. Well, luckily there are component values. PNP transistor. The coil that sets the frequency is here. It is a series tuning, not parallel tuning. In series tuning, the capacitor is in series with the coil that is responsible for the frequency. So the capacitor here sets the frequency band. Good idea, I think it's useful. Use here, for instance, say for a first begin, to get to the, say, approximately 1 megahertz. Use here, for instance, 60 windings or 100 windings on a toilet roll, and this capacitor between, say, 10 and 500 picofarad. Well, here the same thing, but now it's a crystal. And we know from the radio theory that a crystal can be, say, in a certain way compared to a coil. But a coil with an extremely high quality factor. So, when you want to know more, go to the World Wide Web. And there are circuits on my YouTube channel where I also tell about this way of making a working oscillator, where I use a crystal and where I use, say, a ceramic filter. That can also be used as a kind of coil. I have to explain that better, but anyway. What's this? Again, a transistor crystal oscillator. As far as I know, this is a kind of Pierce oscillator. My camera will stop suddenly. I'm on 15 minutes. 100 kilocycles crystal oscillator. You can use here a BC557. As far as I know. I think this is originally a germanium transistor. And when you use a BC557, perhaps this voltage must be somewhat higher, say 3 volts. Differentiator, and well, a differentiator gives out a typical certain waveform. Go to the World Wide Web for more explanation, and there is also a video on my YouTube channel about differentiators and integrators. Two very basic circuits that you can use in electronics. Thanks for watching. I stopped the video now. I'm on 15 minutes. Well, that's quite long for me. Thanks for watching.